In this video, we are going to discuss integration of a function in the form involving a denominator of square root 25x squared minus 4. Such an integration can be performed by using a trigonometric substitution of the form x equals to a secant theta. We proceed with the integration by mapping the square root term to a right triangle with the height having the values of the square root. We'll label the angle of the right triangle here as theta. Once you have labeled the height of the right triangle to be the square root and label the angle theta, you can then use Pythagoras theorem to label the hypotenuse and the base of the right triangle. The hypotenuse should have the length of 5x because this represents the square of the hypotenuse. 4 represents the square of the base, so the base would have a length of 2. The mapping of the square root term to the right triangle as shown here is a very crucial step for performing the integration using the trigonometric substitution rule, which we are going to discuss now. The identifications or the mapping of the square root to the right triangle is not unique. You can equally label the base to be the square root term and the height to be having a values of 2. Both identifications are valid approaches, but we will proceed with the integration by choosing the vertical height as the square root term. Once the right triangle is written down, then we can proceed to relate the angle to the hypotenuse and the base. This is simply obtained by realizing that the secant of theta, which is by definition 1 over cos theta, is just simply equals to 2 over 5x. Reverting this relationship and make x as the title, we have x equals to 2 over 5 secant theta. This is in the form of a secant theta. Here, the values of a is simply 2 over 5. Proceed with the integration. We have to obtain the expression for dx as well as the expression of the square root term in terms of theta. The dx term could be easily obtained by taking the differential of x to give you 2/5 secant theta tangent theta d theta. The expressions of the square root term can be simplified to 2 times square root of secant squared theta minus 1. This expression can be further simplified to 2 tangent theta by using the identity of secant squared theta minus 1 equals to tangent squared theta. So now we have the expression of dx as well as the expression of the square root term. We then proceed to write down the integration in x into the integrations in terms of theta. The dx term is simply this, which is 2 over 5 secant theta tangent theta. The denominator is simply 2 tangent theta. We cancel off the tangent theta to arrive at 1/5 integrations of secant theta d theta. Integrations of secant theta has been discussed previously. It is given by log of absolute values of secant theta plus tangent theta, and we have a constant term here. Now we have to translate the secant theta and tangent theta back to the expression of x. Secant theta in terms of x is simply 5x over 2, so we replace secant theta by 5 over x. The tangent theta term can be obtained by referring to this triangle. Tangent theta is equals to the ratio of the opposite divided by the adjacent. So I'll copy this tangent theta expression and paste it here so that I can refer to it to write down the expression of tangent theta in terms of x. So we have completed the integrations of example 24, and this is the result of the integrations. As a conclusion, we have performed the integrations for example 24, where the integrand contains a denominator of square root of 25x squared minus 4. We first map the square root term to the height of a right triangle with an angle theta label for this angle. With this choice, you can then realize the hypotenuse for the triangle should be 5x and the adjacent should take the values of 2. Based on this triangle, you then write down the relationship between the angle and the hypotenuse and the adjacent. That is, the secant of theta is just simply 5x over 2. Turning it around, you'll be able to express the variable x in terms of the theta through this trigonometric substitution. The next thing is then to translate the integration with respect to x into the integration with respect to theta by using this substitution rule. Substituting x into variable theta will then arrive at the integrations in terms of secant theta. In the process, you realize that you have to make use of the relationship between secant squared theta and tangent squared theta. The integrations of secant theta is then performed to arrive at the expressions of the integration in terms of secant theta and tangent theta. We have to then translate the secant theta and tangent theta back to the expressions in terms of x. The translation from theta back to x can be done by referring to the triangle. The triangle gives you a relationship between x and secant theta. So you recover this term 5x over 2 for the secant theta term. For the tangent theta, you can obtain this relationship from the triangle. Putting everything together, you arrive at the integrations of the example 24 in terms of x. So this has completed our discussions of performing the integrations that involve an denominator in the general form of a square root of x squared minus n constant a squared.